We're only going to do 4 sections over circles, and then we have like a big old worksheet over this on Wednesday next week. Okay, so today, tangent lines. We've talked about tangent in relation to right triangles already, how the tangent is the opposite side over the adjacent side. Tangent in relation to a circle is a line, segment, or ray that intersects the circle at exactly one point. So to be tangent to something, that means you only intersect it at one point. The point of intersection is called the point of tangency then. So your little picture here, B is the point on this line that is also on the circle. So we would say that point B is the point of tangency. And then the bottom one is pointing to that line AB, and we would call that our tangent line. To be tangent means you intersect it at one point. It's going to look like more than one point on the smartboard and on your paper because I have to make it thick enough so you can see it. But it means it's only intersecting it at one point. These next 2 terms, we've kind of talked about them back in chapter 5 before Christmas. An inscribed polygon is when it's on the inside of the circle. And each vertex of the polygon is touching the circle at one point. So this first image, the square is inscribed in the circle. Each corner of the square is intersecting that circle at those 4 points. This triangle is inscribed in the circle. Inscribed is referring to the figure on the inside. If you say something is circumscribed about, then that means it's going around the figure. So in this image, the triangle is circumscribed about the circle. It's on the outside of it. The triangle is intersecting the circle at only one point. There's one point here, there's one point here, and there's one point here where it's hitting it. It looks like more than one, but they're just tangent at those points. 3 theorems for the day. The first one. If a line is tangent to a circle, then that line is perpendicular to the radius. What does it mean to be perpendicular again? Yeah, make a 90-degree angle. So if I were to say that AB is tangent to the circle, then it's only intersecting at point P. Since OP is a radius, then they're going to form a right angle there at P. A tangent line is perpendicular to the radius. Tangent line is perpendicular to the radius. The next theorem is this guy's converse. That goes back to first semester where we just flip the if and then around. If a line is perpendicular to the radius, then it's a tangent line. So if I see that right angle, I know that AB is a tangent to the circle. Tangent line, perpendicular. Perpendicular means it's a tangent line. The only thing that I think relates tangent of a circle to the tangent of a triangle is that it deals with right angles. Otherwise, there's not much relation. Then your third theorem there on the bottom says that if you have 2 tangent lines, segments, I guess, that start from the same point on the outside of the circle, so BA and BC are tangent and they both start at B, then those tangent segments are going to be congruent. You have a tangent segment, starts at the same point outside of the circle and goes to the same circle, they're going to be congruent then. So we're going to take these 3 theorems and we're going to find angle measures and lengths of sides and whatnot on your backside. It says that BA is tangent to circle C at point A. Find the value of X. Melissa, if a segment is tangent to the circle, then the segment and the radius form a what? Yeah, which letter, A, B, or C, would be my 90? Good. Tangent and a radius are going to form a right angle, so we have a right angle at A. Kendra, how are we going to find the value of x then? Good. Use the triangle sum theorem? Yeah, awesome. Triangle sum theorem says that all three angles have to add up to 180. $68. Good on number one. Okay. Tangent and a radius are going to form a right angle. Number two, ML and MN are tangent to circle O. Find the value of x. What do you guys think? What can we do here? If you hear lines being tangent to circles, hopefully an angle measure comes up. What angle measure pops in your head? Good, Bree. Which ones would be 90? Yes. ML is tangent to the circle, so it's going to make a 90 with the radius. MN is tangent to our circle, so it's going to make a 90 with the radius. What do you think, Linz? How can I find x then? Cut the triangle in half. What triangle? Oh. Are you sure you don't know what to do? You probably do know what to do. Is this circle a polygon? No, good, because it has curves. Is there a polygon in that picture? Something made of no curves? Something made of segments? Yeah.
No, I hate when you put me on the spot.
There's only 14 of us in here today, Linz. You're all right. Oh, okay. I'll be sure next time to see if you're not tired. Okay, see this segment and this one and this one and this one? How many are there? So what kind of polygon is that, Linz? Good. Do you know anything about the angles of a quad? You got it figured out. Can we find x? Yeah, if I add everything I know and then subtract it from what? Good. Hey, you know when you said split that triangle in half, did you mean that? You could do that. You just have to then cut 117 in half. And then find this one using triangle sum theorem and then double it again at the end, right? Yeah. And it would have worked just fine. Okay. 90 plus 90, Linz. Good. And then I'm going to add 117 to that. So I get 297. And then you said I have to subtract that from 360. Trevor, what did you keep whispering over there? Good. Taylor, there was a rule on the front side that talked about tangent lines coming from the same point. Then those tangent lines are what? Good. So then LM would be congruent to NM, right? Okay. Nick, OL and ON, what are those things in my circle? Were they going to be the same length or different? They would be the same length. What kind of quad is that? What, Zach? Good, that's a kite. There's a kite in there. I don't know. Something to review for your semester test. Kites have two pairs of congruent sides. All right. Here we go. Number 3. A belt fits tightly around two circular pulleys as shown. Okay. We're back in 2-dimension, guys. There's not going to be any like cylinders or cones or prisms in this chapter. Okay, so don't try and envision this as a weird cylinder or something. I think of this kind of as your bike chain. You got your big gear and your little gear, and then you've got your chain going around it. Okay, something sort of like that. But it says find the distance between the centers of the pulleys. O being the center here, and P being the center there. We're trying to find the distance between them, or the length of that line. I'm just going to call it M. So we're trying to find the value of M, which is the length of OP. Any thoughts? Can't go around. Just give me an idea. Anything we could think to do. One has to be a right angle. So then I have a rectangle. ZW is 15. OL, that red line I just drew in, how long would that one have to be? 15. We know what OZ is. What's OZ? Then LW would have to be what? 3. Would we figure out any other length from that? LP, what's LP going to be? Good. LP is going to be 4 because PY is 7. That's a radius. PW has to be 7. Lens, if this angle is 90, the one adjacent to it has to be what? So now we have triangle OLP. What kind of triangle is it? A right triangle, and OP, the side length I'm trying to find, represents its what? Its hypotenuse. So then what theorem should I use? Okay, finish it, round it to the 10th. Andrew, thanks for your idea. Draw the line segment from the little circle to the big circle so that you get a rectangle and a right triangle. I don't know, because you're just right in front of me. And when I call on people, then usually someone else's attention's grabbed too. What'd you come up with for M?
I got 15.
Good. Spencer, this one's not on your note packet. It says ED is tangent to circle O. Find the value of X. Tell me what I should do, Spence. Why can I put a 90 degree at D? Good, because it's tangent to the circle. So then what do I have to do, Spencer, to find X? Good job. Excellent. Ross, this one is not on your note packet. How would we determine if ML was tangent to circle N? Okay. Remember, it's hard to tell on my computer screen because I got to make it big enough. How would we know for sure or not? It was really only touching it at L. How are we going to figure out if it's perpendicular to the radius? How can I figure out the angle measurement? Well, if it was perpendicular, what angle would be there? So what kind of triangle would we make? So what theorem could I use to back up our thought process here? You don't know? What theorem works when we want to know whether or not if it's a right triangle or not? The Pythagorean. It's just its converse. That was, I think, the one day you were gone. Actually, now that I think of it. It was, because when it was c squared was less than, we called it an acute triangle, and when it was greater than, it was obtuse. But if they're equal, it's a right triangle, so we would use the converse here and say 4 squared plus 7 squared equals 8 squared. 4 squared, guys. 7 squared. 16 plus 49. 65. What's 8 squared? Are they equal? So is it a right triangle? So is it tangent? C squared is less than. What kind of triangle is it? Acute. Good. This one's on your note packet. Circle C is inscribed in quad XYZW. Inscribed means it's on the inside. We have to find the perimeter of quad XYZW. Sam, how do you find the perimeter of any polygon? So I know XY is 19. And I can figure out that ZW is 13. Sam, how are we going to figure out what the other side lengths are? You're not getting out of it that easy. Watch out, you're next.
Me?
Yeah, yeah.
Why?
Hold on a minute.
It's not.
It's kind of like how we figured out that on number 2 we had a kite there in the picture. You know where your calculator's at right now? Okay. Which ones? That whole thing is? Why? What's that theorem say, Sam? Okay, so the two segments that... Good. XU and XR would have to be congruent because they can only be congruent up to the tangent, right? So what's XU then? Okay. But then I got to figure out what UW is, Sam. Sam, CUW? Where does it start at? Yeah, it starts at U and goes to where? Do I have another segment that's at W? And it goes up. It's 7, good, because that's got to be congruent to TW, right? Okay, so I know down this side length is 18. What about at the top, Sam? What's YS going to be? What about SZ? So then, Sam, YZ? Yeah. Good. So then the perimeter, wouldn't I just have to add these 4 values up, Sam? Or I could add 8, the tiny 8 ones, right? Okay. Trevor, when you add all that up, what do you get for a perimeter? Good. All right, do the last one. Circle O is inscribed in triangle PQR and has a perimeter of 88. Find QY. Nick. ZR is 17. And what other segment's going to be 17? Good. PX is 15. Which other one has to be 15? Good. I'm trying to find QY. I don't know. I'll call it W. So what other one's going to be W? And all of these added together have to equal what? Good. So 15 and 15 would give me 30. And 17 plus 17 is going to give me 34. And a W plus another W give me 2W? Sure. Taylor, 30 plus 34? How do I bring that over, Taylor? 88 minus 64? 24. Good job. How do I get rid of the 2? 24 divided by 2? Good. I was hoping you didn't use your calculator on that one. QI equals 12. You maybe don't have to write out a whole algebraic equation. You did it differently, but hopefully you get to 12. Questions on tangents. What do they make with the radius? A right angle. And if 2 of them start at the same point and go to the circle, then they're what? Congruent. Good.